All right, so in this video, we're going to solve quadratic equations using the quadratic formula, okay? You should have recently watched the video on using the discriminant with the quadratic formula to determine how many solutions each quadratic equation will have and what kind of solutions those will be. Okay, so you've seen this quadratic formula recently. Okay, you need to memorize it. There are some songs out there that can help you memorize it. I'm not going to go over the song, but the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. All of that divided by 2a, okay? So in order to use the quadratic formula, we need a quadratic equation, and we need everything to be on one side set equal to 0, okay, in standard form, so we can find the values for a, b, and c, okay? So first thing with example 6a here is I want to move this -9 over to the left side and get everything on one side set equal to 0, all right? So x squared plus 6x plus 9 equals 0, okay? So now I can label a as 1, b as 6, and c is 9, okay? And now, like I said, we're just gonna plug everything in here, do a little math, and we're gonna find the solution or solutions for this quadratic equation, okay? This one could be factored, okay? You could solve this one by factoring, but we're working on the quadratic formula here, so let's just do that, okay? So let's plug everything in. So it's gonna be -6, so the opposite of b, plus or minus b squared, so b was 6, so 6 squared minus 4 times a, which was 1, times c, which was 9, all that divided by 2 times a, okay? So now we're going to simplify what's underneath the radical here, and we'll simplify the denominator, okay? So I've got -6 plus or minus 36 minus 36, okay? All that divided by 2. So I can see now my discriminant is 0, okay? And if you'll think back to the previous video, that means I'm only going to have one solution. It's going to be real. It's going to be rational. All right? So that gives me -6 plus or minus the square root of 0 over 2. We know this part is going to go away. So I'm just left with -6 over 2, which is -3. All right? So the only solution for this equation is -3. Okay? Most of the quadratics we're going to work with are going to have 2 solutions. All right, so pause the video, give B a try. Make sure you get everything on one side set equal to 0 first. It doesn't matter if you want to get everything on the left side, if you want to get everything on the right side, doesn't matter. So pause the video, give it a try, and then come back. Okay, so let's write this in standard form first. I'm going to bring everything over to the left side, so I'm going to add this x squared over here. That gives me -7x squared. -5x doesn't change, and then this -1 moves over to the left side and becomes positive, okay? If you took everything to the right side, just all these signs would be different. It'd be 7x squared plus 5x minus 1, and that's not going to change the outcome when you use the quadratic formula, okay? Even though the signs are all different, this will take care of that, okay? Signs are not going to be an issue, assuming you did everything correctly. All right, so a is -7 for me, b is -5, c is +1. Okay, let's plug everything in, and we get the opposite of b, so the opposite of -5, plus or minus b squared, so -5 squared. Make sure that's in parentheses, because we want to get a +25 when we simplify that. -4 times -7 times 1, all over 2 times -7. Okay, so let's kind of clean everything up. So the opposite of -5 is +5. Okay, -5 to the second power is +25, and then -4 times -7 times 1 is +28, okay? All that divided by -14, okay? My discriminant here, 25 plus 28, is going to be +53, okay? That means I have 2 solutions. They're going to be real solutions, okay? Not imaginary or complex. Okay, but because 53 is a prime number with no perfect square factors, and it's not a perfect square, excuse me, my solutions are going to be what we call irrational, okay? And I'm going to leave them in radical form here, okay? So I can't have a negative number in the denominator, so I'm just going to divide everything kind of by a -1 or multiply everything by a -1. So my final answer should be -5, okay? This 5 switches from positive to negative. This 14 switches from negative to positive. And this plus or minus, technically it switches, okay, but we still are going to write it using the plus or minus, okay? So this kind of takes care of itself, all right? So my 2 answers are -5 plus radical 53 over 14, okay? You can use a calculator to figure out exactly what that is, okay? And you can get negative 5 minus radical 53 over 14, okay? So there are two solutions in here. They are real and they are irrational, okay? And C, let's give this one a try. We're already in the form we need to be, so we can just label A, B, and C. A is positive 3, B is negative 3, C is positive 5, okay? Let's plug everything in, okay? So I've got the opposite of B, so the opposite of negative 3, plus or minus B squared minus 4 times A times C, all divided by 2A, okay? So let's clean up these three parts. So the opposite of negative 3 is positive 3, negative 3 squared is positive 9, negative 4 times 3 times 5 is negative 60, all divided by 6, okay? So underneath the radical, my discriminant's a negative 51, okay? That means I'm gonna have imaginary or complex solutions. I'm gonna have two of those, all right? I can't simplify 51, okay? The 51 doesn't have any perfect square factors. It's not prime, like 53 was prime. It's not prime, but the factors that it does have don't include a perfect square, okay? So I get 3 plus or minus I radical 51. I'm gonna factor out a negative 1 here and take that out as an I, okay? Now this 3 over 6 can be simplified. We just need to be careful how we do that. So I can break down that 3 over 6 to 1/2, okay? And then this plus or minus I radical 51 also has to be over 6. That can't be simplified any. So my final answer, two solutions, 1/2 plus or minus I radical 51 over 6. Okay, that's it.